Good evening, everyone. I'm Tanmay. Today we are going to discuss a topic in probability and statistics, which is difference between single tail and two tail test. And also we are going to test the hypothesis of uh, difference between means and single mean uh, for a large sample. Now coming to the difference between one tail and two tail test. Uh, the first difference is purpose. We use this one tail test when the research hypothesis uh, specifies a direction of the effect, which means it can be either greater than, less than, but it specifies the direction of the effect. Uh, which means we are going to specify the possibility of relationship in only one direction. The next difference is hypothesis, which is null hypothesis and alternative hypothesis. Null hypothesis means which means no effect or no difference. For example, it is denoted by h naught. Here the null hypothesis h naught equal to mu naught. Next one is alternate hypothesis. It is represented by h1, which specifies the direction of the effect, which means h1 mu is greater than mu naught or mu is less than mu naught. Here we told it specifies the direction of effect in either greater than or less than, right? So here mu is greater than mu naught or mu is less than mu naught. Next, critical region. Critical region means it is where the null hypothesis is rejected. Here, the critical region is located in one tail of distribution, uh, which can be either right tail or left tail. If H1, which is alternate hypothesis, mu greater than mu naught, then the critical region is in right tail. If H1, which is alternate hypothesis, then mu is less than mu naught, then it is a left tail. If greater than means right tail and less than means left tail. Next difference is significance level, which means the entire alpha level. If here we are taking 0.05 as an example, it is placed in either only in one tail of the distribution. Uh, Let us take an example for one tail. If we are testing a new drug, which is more effective than to test a new drug, to check whether it is effective than the current drug, we are using this one tail test. Next, two tail test. The same differences we are going to discuss here, which is first one is purpose. A two tail test is used when the research hypothesis does not specify the direction of the effect. Before we known that it specifies the direction in only one way, which means either left or right. Here, it does not specify the direction of the effect. Uh, Next, hypothesis. Here also we have two hypotheses, null hypothesis, alternative hypothesis, null hypothesis H0 and alternative hypothesis H1. Like before, null hypothesis means no effect or no difference. H0, which means mu equal to mu naught. Here, alternate hypothesis does not specify the direction of the effect, which means H1 is not equal to H0. Before, we known that H1 is mu is greater than mu naught or mu is less than mu naught because it specifies the direction. Here, it does not specify the direction. So, mu is not equal to mu naught. Next, critical direction. Critical region. Critical region means we know that critical region means the null hypothesis place where null hypothesis is rejected. Here, the critical region is split between two tails of distribution. Before it is in one tail. There are two critical regions, one in the left tail and another in the right tail. Significance level, which means alpha level is split between the two tails. Suppose the alpha level is 0.05, which means it splits in two tails, which is 0.25 for each. 0.025 for each. Example, if you want to test if a new technique method affects the test sources differently, uh, uh, means if there is a traditional method and if we want to test whether the new technique we introduced affects the test scores differently or not, we are using this two tail test. Uh, so we have discussed five differences, which are purpose, hypothesis, critical region, significance level, and an example for each. Moving to the next topic, which is test the hypothesis for a single mean. Uh, there are 5 steps for testing a hypothesis in either single mean or difference of means. First step is null hypothesis, which we are going to find this is a process how we are going to find the null test the hypothesis for single mean, which means this is a procedure. Next, we are going to apply this procedure in an example. So first, let us know the procedure to do this. First step is null hypothesis, which means we are representing it by h naught x bar equal to mu, which means whether we need to find whether there is no significant difference between the sample mean and population mean, or the sample has been drawn from the population. Alternate hypothesis H1, x bar is not equal to mu naught, or x bar is less than mu naught, or x bar is greater than mu naught. We need to find which value of this sets for the alternate hypothesis. Next, the level of significance alpha, set a level of significance for the hypothesis. Next, we need to find the test statistic. If standard deviation of the population sigma is known, then the test statistic formula is x bar minus mu by sigma by root n. If standard deviation of the population is not known, in this case, we are going to use the standard deviation of the sample, which means test statistics z equal to x bar minus mu by s by root n. Here, the standard deviation of the population is represented by sigma, and standard deviation of the sample is represented by capital S. So, fifth step, which is conclusion, which means we are drawing a conclusion from the above steps. First, if x bar is less than x alpha, then we accept the null hypothesis h naught. If x is greater than x alpha, then we reject the null hypothesis, which means we are accepting the alternate hypothesis h1. So we are going to apply the above procedure in a problem. Taking a problem which goes on like, according to the norms established for a mechanical aptitude test, persons who are 18 years old have an average height of 73.2 with a standard deviation of 8.6. If 31 randomly selected persons of that age average 76.7, test the hypothesis mu equal to 73.2 against the alternate hypothesis mu greater than 73.2 at the 0.01 level of significance. So first we are going to write the given data, which means sample size n equal to 31. See here they gave if the 31 randomly selected person. So we know that n equal to 31 and mean 76.7, sample mean 76.7 here. Next, the population mean mu equal to 73.2. Population standard deviation, they have given 8.6. So this is the data that they have given. So the first step is null hypothesis h naught, which means mu equal to 73.2. Means we need to check here, as I told, we need to check whether there is no significant difference between the sample mean or population mean, or the sample has been drawn from the population. So from this, we know that there is no significant difference between sample population mean and sample mean. So the sample is drawn from the population. Next, alternate hypothesis H1. We know mu is greater than 73.2, which means it is right tail test. See, before I told you mu greater than mu naught right tail test. So as mu naught is 73.2, here mu is greater than 73.2. So it is right tail test, level of significance, which means alpha. Alpha, we are setting it as 0.01. Single tail test 0.05 minus alpha, which is 0.05 0.5 minus 0.01, which is 0.49. Next, we need to find the test statistic. Since we know alpha, which means standard deviation of the population, we are going to use, since we know sigma, which is standard deviation of the population, we are going to use the formula x bar minus mu by sigma by root n. So x bar is 76.7 minus 73.2 by sigma is here, they have given 8.6. So 8.6 by root 31, which is sample is 31. So we get, by calculating this, we get 2.2659. So we are going to draw a conclusion from the above Z value, test statistic value. So the calculated value of Z tab is 2.33. They have given. Next, the calculated value of Z which means we calculated before, is 2.2659, which means the calculated value is less than the tabulated value. If zcal is less than ztab, the null hypothesis is accepted, which means there is no significant difference between the sample mean and population mean, or the sample is drawn from the population. Totally, the null hypothesis is accepted in the above single mean problem. Next, we are going to test the significance for a difference of mean. Here also we have 5 steps, which is null hypothesis, alternate hypothesis, level of significance, test statistic, and a conclusion. First one is null hypothesis, which is null hypothesis is represented by H0, which means x1 is equal to x2. We are going to check x1 is x1 bar equal to x2 bar, or mu1 is equal to mu2. There is no significant difference between mean of the population, or the two samples have been drawn from the same population. Next one, like before, we are going to check alternate hypothesis, that is x1 bar is not equal to x2 bar, or mu1 is not equal to mu2. Next, we are going to set a level of significance. Next, we are going to calculate a test statistic. There are two cases for calculating a test statistic. That is, like before, we are going to check whether a standard deviation of the population is known. So if standard deviation of the population sigma 1, sigma 2 are given, then z value is z1 x1 bar minus x2 bar by sigma root of sigma square by n1 plus sigma 2 square by n2. So when samples are taken from the same population, then the test statistic z equal to x1 bar minus x2 bar by root of sigma square by n1 plus sigma square by n2. Next, this is case 2, which means the standard deviation of the population is not known. Then, like before, we are going to take the standard deviation of the sample, which is x1 bar minus x2 bar by root of s1 square by n1 plus s2 square by n2. Here, s is the standard deviation of the sample. Next, we are going to draw a conclusion from the above z value. If z is less than z alpha, then we accept the null hypothesis. If z is greater than z alpha, then we reject the null hypothesis, which means we are accepting the alternate hypothesis H1. Next, we are going to apply this in a problem. Here, they have given the average marks scored by 32 boys is 72 and with a standard deviation of 8, while that of 36 girls is 70 with a standard deviation of 6. Does this indicate that the boys perform better than girls at a level of significance 0.05? Here the given values are n1, which is the number of boys is 32, and x1 bar, which is mean, equal to 72, and sigma 1 is 8, which is standard deviation of boys. N2 is 36, which is number of girls. X2 bar is 70, which is mean of girls, and sigma 2 is 6, which is standard deviation of girls. So this is the given data. Next, so first we need to find, we are going to find whether the null hypothesis is accepted or rejected by 5 steps. First we are going to find the null hypothesis H0. Here, mu1 is equal to mu2. So the two samples can be drawn from the same population. Next, alternate hypothesis, mu1 is greater than mu2, which means boys are better than girls. Right tail test, level of significance, alpha equal to 0.05. So 0.5 minus 0.05 is 0.45. Next, give the z value which is tabulated is 1.645. The test statistics z equal to x1 bar minus x2 bar by sigma 1 square by n1 plus sigma 2 square by n2. Here we are taking the first case formula because we know the standard deviation of the population. So we are going to use sigma not s. 72 minus 70 by 64 by 32 plus 36 by 36. The calculated z value is 1.1547. So we are going to draw a conclusion from this. The tabulated value z tab is 1.645 and calculated value is z cal is 1.545. So here the calculated value is less than the tabulated value. So the null hypothesis is accepted. Thank you.